To my class. In today's class we are going to be discussing about few problems related to the equation of continuity and Bernoulli's theorem and its applications. Here the first question is given as a liquid enters a tube of variable cross section with a velocity is given as 3 meter per second through the wider end, and it leaves from the narrower end whose radius is given as half that of the wider end is given. So the velocity with which it leaves the tube they are asking. Here one tube is given. Now here the fluid is going to be entering with the wider end. Let us take this radius we can take as r we can take, and here it is going to be leaving to the another end. This radius is given as r by 2. Radius is half that of the wider end is given. So the liquid is going to be entering with the into this tube will be v1 you can take, and the liquid which is leaving from the tube you can take as v2 you can take. Here you can take according to the equation of continuity. According to equation of continuity, the volume of the fluid which is entering in a given time, which will be equal to the same volume of the fluid which is leaving from the another end, will be getting in the same time interval a1 v1, which will be equal to, you can write it as a2 v2. Here area of cross section, the sense here you can take it as pi r square across the first end into its velocity is given as 3 meter per second. The another end it's given as pi into r square, its radius is given as r by 2 whole square into, you can take as v2 you can take. Here pi gets cancelled. Here one r square gets cancelled. Here 3 into you will be getting it. This is r square by 4 will be getting 1 by 4 into, you can take as v2. Then velocity v2 which will be equal to, when you are doing cross multiplication, this is 12 meter per second will be getting. So with what velocity the fluid is leaving from the another end, in the sense 12 meter per second will be getting. Look at the next question. The work done by the pressure in forcing 2 meter cube of the volume of water through a pipe of radius 1 centimeter if the pressure difference across the pipe is given as 5 Pascal. So here the pipe is given. There is a pressure difference will be getting across the pipe, and here you are going to be forcing 2 meter cube of the water. You are going to be forcing 2 meter cube of the water. That means here volume is given and its radius is given as 1 centimeter is given. The pressure difference across the pipe is given as, here this is P1 and this is P2 you can take. It's given as 10 power 5 Pascal it's given. So work done by the fluid due to the pressure differences, the formula will be getting as W equals to P into, you can take as V you can take. Work done by the fluid due to the pressure difference, the formula will be W equals, will be getting as P into V. Means here the some liquid is going to be entering, it creates some pressure here, and this side when it is leaving here it will create some pressure. So that pressure difference let us take as this is delta P also you can write. So here W equals to, you can write it as P into delta P into V, in the sense delta P is given as 10 power 5 Pascal is given. So 10 power 5 into its volume will be here 2 meter cube is given. So therefore W equals, here what will be getting 2 into, you can take as 10 power 5, the units of the work done which will be equal to joules will be getting. So this is 2 into 10 power 5 joules is the correct answer. Look at the next question. In a horizontal pipeline, pressure falls by 10 Pascal between the 2 points separated by a distance 1 kilometer. So here it's given as a horizontal pipe is given. Its separation it's given as 1 kilometer, it's given 1 kilometer separation, Now the liquid is going to be entering and as well as the liquid is going to be leaving from the tube. The change in kinetic energy per kg of the oil when oil flows from one point to the another point. So change in kinetic energy here we need to calculate. This is Bernoulli's theorem principle. According to Bernoulli's theorem, the sum of the pressure energy plus potential energy plus kinetic energy per unit volume remains constant. So P1 plus here you can get it as rho GH plus half rho V square, which will be equal to constant we will be getting. If the tube is horizontal means here we can eliminate this height value. Therefore the formula will be getting as P1 plus half rho V square, which will be equal to constant we will be getting. Let us take here, this is P itself you have to talk. So two values when you are talking here, you can write as P1 plus half rho V1 square, which will be equal to P2 plus here you can write as half rho into V2 square you can take. So the pressure difference will be P1 minus P2, which will be equal to half into you will be getting as rho into you can write as V2 square minus V1 square. So this will be P1 minus P2 by rho you can take, which will be equal to half into you can get it as V2 square minus V1 square will be getting. So here they are asking the change in kinetic energy of the oil per kg of the oil. Change in kinetic energy per kg, half m change V2 minus V2 square minus V1 square per kg of the oil means per mass they are asking. So here mass gets cancelled, half into V2 square minus V1 square. This is the requirement of the question. So change in kinetic energy per mass, in the sense here we will be getting the formula will be half into V1 square minus V2 square minus V1 square will be getting. So here in the question is given as pressure falls by, it is given as 10 Pascal. This is half into V2 square minus V1 square, which will be equal to 10 by pressure falls by 10 Pascal it's given, and here its density is given as here 800 it's given. So here 10 gets cancelled, here we will be getting as 1 by 80 joules you will be getting. So this will be the correct answer. Look at the next question. Volume of the liquid flowing per second through a pipe of diameter d is V given at a point where the radius is d. The velocity of the flow they are asking. Volume of the liquid flowing per second through a pipe according to the equation of continuity. According to equation of continuity. According to equation of continuity, the volume of the fluid which is flowing per second through a pipe is, the formula will be V equal to A1 V1, which will be equal to A2 V2. So here V equal to, at a point where the radius is d, the velocity they are asking. So here that means here V equal to, here we can talk about A into V at a given distance, means here at pi r square into will be getting as velocity will be V will be taking. But here at a point where the radius is d, there we can calculate the velocity of the flow. So here instead of radius, here it is given as d is given. So we need to substitute pi into d square into its velocity. This is volume of the fluid which is flowing per second. So then here we require the velocity, then V equal to volume of the fluid flowing per second by, here we will be getting as pi d square will be getting. So this will be the correct answer. V by pi d square you are getting. Look at the next question. Water is flowing through a horizontal pipe of variable cross section. the rate of volume flow is given as 0.2 liter per second is given. The pressure is given as here 30,000 Pascal at a point where the area of cross section is 5 into 10 power minus 5 meter square. The pressure at the point where the area of cross section is 10 power minus 4 is they're asking. So here this area of cross section and another end it's given. This is also meter square you have to consider. So we need to calculate the pressure at a particular point. Here you just look at when water is flowing along the horizontal pipe. So we know the formula according to the Bernoulli's theorem. First let us talk about volume of the fluid which is entering into the tube. V equal to, you can get it as A1 V1 across the first end. Across the first end here the volume of fluid is going to be entering and as well as leaving, and this will be here you can get as A1, and here another radius is given as, here you can get it as, this is somewhat smaller one you can get, and here you will be getting like this. Right, how much volume is given as 0.2 liter per second is given. 0.2 into 1 liter equal to 10 power minus 3 meter cube you are getting, equal to area of cross section across the first one it's given as 5 into 10 power minus 5 into its velocity we don't know, let us calculate V1 value. So here 10 power minus 3 and 10 power minus 3 gets cancelled, it will be 10 power minus 2. So V1 equal to, will be writing as 0.2 by 5 into 10 power minus 2. When it goes to the numerator, 10 power plus 2. 2 into 10 power 0.2 into here you can get it as 10 power 2 by 5 you can get. Then V1 equals to 0.2 into 100 is 20 by 5 you can write. So it will be 4 times. Here we will be getting as 4 meter per second. That means here the liquid across the first one it's going to be entering in the tube is 4 meter per second. Now here you just calculate the V2 also, with what velocity the fluid is going to be leaving according to the equation of continuity. Again here 0.2 into volume of the fluid which is leaving from the tube will be, you can take as A2 V2 you can talk. The same volume of the fluid which is going to be leaving across another end also, this will be the V2 you can take. So here 0.2 into 1 liter equal to 10 power minus 3 meter cube. Across another end the area is given as 10 power minus 4 meter square into V2 you can calculate. Here 10 power minus 3 and 10 power minus 3 gets cancelled. Therefore velocity V2 equal to 0.2 by 10 power minus 1 will be writing. So 0.2 into 10, here when it comes to the numerator, here it becomes 2 meter per second will be getting. Now we have calculated the V1 value across the first end, V2 value across the second end. Now the tube is given as horizontal. If the tube is given as horizontal, according to the Bernoulli's theorem, here you can take P plus half rho V square which will be equal to constant. This is sum of the pressure energy plus kinetic energy per unit volume remains constant will be writing. So on both sides two values when you are talking, P1 plus half rho V1 square which will be equivalent to P2 plus, here you can take as half rho into V2 square you can take. Then we require the P2 value, P2 which will be equal to P1 plus half into rho into, you can write it as, you just bring this side, V1 square minus V2 square you are getting. So here P1 initial pressure across the first end of the tube is given as 30,000 Pascal plus half into density of the water is 10 power 3 V1, V2 we have calculated already, V1 right, 4 4s are 16 minus here you will be writing as 2 2s are 4 will be getting. So 16 minus 4 is 12, and here when you are simplifying this one, this is 30,000 plus this is here 10 cube we will be getting, this is 1000, and this is 12 by 2 you can write into 10 power 3, 2 6 are 6000 plus, see, this is 6000 we will be getting plus 30,000, together we will be writing as 36,000 Pascal we will be writing. So final pressure at the another end will be 36,000 Pascal is the correct answer. Now look at the next question. Due to the disease, the main artery enlarged and area of cross section becomes 1.6 times the previous value. The speed of the blood in the enlarged artery is given as 0.4 meter per second. The excess pressure on the walls of the artery due to the enlargement they are asking. Excess pressure they are asking, and the density of the blood is given as 1060 kg per meter cube. Here you can take according to equation of continuity principle. According to equation of continuity, here we can write it as volume of the blood which is entering and leaving, you can write as same, you can take A1 V1 which will be equal to, you can write it as A2 V2. Here it is given as area of cross section becomes 1.6 times of the previous value. So here initial area, let us take it as A1 you are taking. With what velocity it is given? It is entering with the 0.4 meter per second, and the other side it is given as 1.6 times of the previous value. Previous one I am taking as A1 into, you can talk as V2, you can take A1 gets cancelled, then V2 which will be equal to, you will be getting as 0.4 by, you can write it as 1.6. So here when you take here 4 4s are, will be getting 1 by 4, in the sense we will be getting as 0.25 meter per second we will be getting. So here according to the Bernoulli's principle, according to Bernoulli's theorem, here you can take P1 plus half rho V1 square which will be equal to P2 plus half rho into V2 square, you can take. So here they are asking the excess pressure in the walls of the artery, means pressure difference we need to calculate. Then P2 minus P1 which will be equal to, we have to bring this side, then here we will be writing as half into rho into V1 square minus V2 square, you can draw, which will be equivalent to half into density of the blood is given as 1060 into V1 square, in the sense here it is given as it's a 0.4 meter per second minus, here we will be writing as 0.25 whole square you will be getting. Even 0.4 you can take as 4 by 10 you can write. So 2 2s are 2 5s are, you can take here 1 by 2 into 1060 into, here you can take as 2 by 5 means 2 2s are 4, 25 you can take minus 0.25 you can write it as 1 by 4, 1 by 4 whole square means here you can write it as 1 by 16 you can take, and you just take the LCM. Then the pressure, excess pressure on the walls of the artery doesn't mean P2 minus P1 which will be equal to, nearly will be getting as 51.675 Pascal you are getting. So this will be the correct answer. Let us see the next question. Air streams horizontally across an aeroplane wing of area 3 meters square. Its weighing is given as 250 kg. The air speed is given as 60 meter per second and 45 meter per second over the top surface and under the bottom surface respectively. It's an aeroplane wing, it's given. Here wing area it's given as 3 meters square, it's given 3 meters square is an area. Its weighing is given as 250 kg. The air speed is given as 60 meter per second and over the top here it's given as 60 meter per second. Over the bottom it's given as 45 meter per second it is given. And here what is the lift on the wing they are asking. So here we have to calculate the lift value. Here you just look at lift of the wing is nothing but aerodynamic lift of the wing. lift of the wing is nothing but force they are asking. Force which will be equal to, you can take as pressure difference into, you can take as area, you can take pressure difference into area. According to Bernoulli's theorem, here we will be writing as according to Bernoulli's theorem. According to Bernoulli's theorem, so here you can write it as P1 plus half rho V1 square, almost you can write it as horizontal, P2 plus, here you can write it as half rho into V2 square. Delta P in the sense here you can write it as this will be P1 minus P2, which will be equal to half into rho into, you can write it as V2 square minus V1 square. This is delta P, you can talk here, this value will be getting as half rho into V2 square minus V1 square. So now here lift of the wing means here it's a aerodynamic lift they are asking. So pressure into area. So here therefore a lift doesn't mean, here you can get it as delta P, we got it as half into rho into V2 square minus V1 square into area. This is an aerodynamic lift formula. Half into, here density of the air it's given as 1.293 into V2 square, it is given as velocity 1 and it's given as, here you can square on both sides, here we'll be getting as 60 meter per second, 60 whole square means 3600 minus another end it's given as bottom it's given as 25 meter per second, 45 meters. So here you can write as 45 whole square means, here you can write it as 2025, 45 whole square into area it's given as 3 meters square it's given. So when you simplify this one, here we'll be getting as 3054 newtons will be getting 3054 newtons. So fourth one is the correct answer. Now look at the next question. The velocity of the air over the upper surface of the wing of an aeroplane is 40 meter per second and that of the lower surface is given as 30 meter per second. Wing of the aeroplane it's given. So here on the top surface, here the velocity will be 40 meter per second. At the bottom it's given as here 30 meter per second. So when the air is going to be flowing here, it's going to be creating some pressure. Wherever the higher velocity, there it creates a lower pressure. Let us take here, this is P1, and here wherever the lower velocity will be there it creates a higher pressure, P2 you can take. Now wing area it's given as, here area of the wing is given as 5 meters square and the mass of the wing is given as 300 kg. The net force acting on the wing they are asking. Net force doesn't mean, here we can take, one is here an upward thrust will be getting, downward force is the upward thrust due to the fluid pressure will be getting, downward force will be getting as due to the weight of the aeroplane will be getting. This is an F upthrust you can talk. Here P equals to, here when you are talking, which will be equal to pressure difference, here you can take according to the Bernoulli's principle, according to Bernoulli's theorem, according to Bernoulli's theorem. According to Bernoulli's theorem, here you can write it as P1 plus half rho V1 square, which will be equal to P2 plus half rho into V2 square you can talk. So here a pressure difference here which will be equal to P1 minus P2, which will be equal to, here you can take it as half into rho into, you can take it as V2 square minus V1 square. Means due to the pressure difference in upward thrust will be getting. So here this value will be half into 1.3 into density of the air it's given, V2 square minus V1 square, that is 40 whole square minus 30 whole square will be getting. When you are simplifying this value, here we will be getting as nearly will be getting as 455 Pascal you are getting. Now net force in the sense, here force equal to pressure into area, force equal to, you can get it as pressure into area. So here you can write it as 455 into area will be 5, will be getting area of the wing is given as 5 meter square, which you are getting as nearly 2275 newtons will be getting. Due to the pressure difference, there is an upthrust will be getting. That upthrust value we have calculated as 2275 newtons you are getting. And the second thing they're asking as mg value. Mg weight, we can talk as weight, which is nothing but mass into g. So here it's given as 300 kg into here it's given as 10. So we'll be getting as 3000 newtons will be getting. F net force, when you are talking net force, here we can take weight, it will be more, will be getting than upthrust. This is an upthrust, we can talk upthrust. So here weight will be more, will be getting the net force. In the sense here we can talk about mg minus f. You can take mg value, it will be 3000 newton minus 2275 newton you can take. So here the resultant value will be getting as 725 newtons will be getting. So weight will be more, will be getting, then here the net force, it's going to be acting in downward direction you are getting. Look at the next question. A horizontal pipe of uniform area of cross section, it allows water to flow it through the velocity 1 meter per second when the pressure is 50 kilopascal at a point. If the velocity of the flow has to be 2 meter per second at some other point, the pressure at that point they are asking. Here it's given as a horizontal uniform cross sectional wire. Here this is a horizontal pipe you can take, and here it's a fluid is entering with 1 meter per second velocity. At this point here the pressure value is given as P1 equal to 50 kilopascal, it's given, and here the velocity, with what velocity it is leaving, is 2 meter per second. Here we can calculate the pressure value P2. Now here you can take according to, so this is basically the problem will be based on the Bernoulli's theorem. According to Bernoulli's theorem, if an horizontal pipe is given, means here you can take as P1 plus half rho V1 square, which will be equal to P2 plus half rho into V2 square you can take. Now here initial pressure is given as 50 kilopascal, then you can take 50 into 10 power 3 plus half into rho, in the sense here you can take as 10 power 3 into 1 square, which will be equal to P2, let us calculate this side, plus half into density of the water value is 10 power 3 into V2 square, it is given as 2 meter per second. 2 square you can take as 4 you can take. Now here this will be 5 into 10 power 4 into this is 500, this is 1000 by 2, you will be getting as 500, which will be equal to P2 plus 1000 by 2 is 500, which will be equal to 2000 will be writing. So when you are simplifying P2 value, you can write it as nearly, so this answer will be getting as 48.5 kilopascal will be getting. This is kilopascal. So in terms of kilos you have to bring, this will be so here this becomes 5 into 50 into 10 power 3, and here 10 power 3. In all the cases here you have to take 10 power 3 you can take common, or else so you just bring this side, then you will be getting the 48.5. in terms of 10 power 3 you can take here, or else you can take this will be 50 into kilo pascal plus this value will be getting as 1 by 2. This is 0.5 into kilo per kilo, which will be equal to P2 plus here you can take as 2 times, here you can take as 2 kilo will be getting. So this value P2, which will be equal to, here you can take as 50 minus 2.7 2.5 will be getting as, all the values will be kilo I am taking, so you will be getting as 48.5 kilopascal will be writing. Look at the next question. A water hose 2 cm in diameter is used to fill 20 liter bucket, it's given. If it takes 1 minute to fill the bucket, then speed V at which water leaves the hose they're asking. Here in the question it's given as water hose 2 centimeter is given. Here a 20 liter bucket is given. It takes 1 minute to fill the bucket. So rate of volume of the flow, what the formula will be getting? Rate of volume flow into the tube, which will be equal to rate of volume of the fluid. It's nothing but volume by time. We can rewrite volume by time. Rate doesn't mean time, volume per unit time. Volume per unit time in a given time, in the sense here you know the formula according to equation of continuity A into V. So here how much volume is going to be filling, in the sense 20 liter. So here 20 liter, 1 liter equal to, you can write it as 1000 ml. 1000 ml I am writing in CGS system. 1 liter which will be equal to 1000 ml. 1 ml equal to 1 milliliter equal to 1 cubic centimeter. You will remember. I am just taking all the values in CGS system. 20 into 10 cube. This is in CC you are writing. By here time is given as here 1 minute is given 60 seconds, which will be equal to area. Area in the sense here you can take as pi r square into you can take as V you can take. Here you just cancel this one. 23 will be getting, and here this is 10 cube by 3, which will be equal to pi into 1 into V you can take. So when you are simplifying this value, radius is given as water is whose diameter is given as 2 centimeter. Radius I am taking as 1 centimeter square I am taking into V. Here left side will be writing in CGS system, right side also you can take in CGS system. Then here water leaves with what velocity, in the sense here will be getting as, when you are calculating these values, 106. This in CGS system will be writing as 106 centimeter per second will be writing. So this will be the correct answer. Now here just look at how much work is done by an agent forcing 3 meter cube of water through a pipe of radius 2 centimeter if the difference of pressure is given as across the ends of the tube is given as 10 power 6 Newton per meter square is given. So here work done by the fluid pressure W equals rating as P into V, or else you can write as P into dV you can take. So pressure difference is given as 10 power 6 Newton per meter square into volume is given as 3 meter cube. So here you can write as 3. Then work done by this fluid pressure W equals to, here we will be getting as 3 into 10 power 6 joules will be getting. Work value will be, work we are measuring in, right, 10 power 6 joules. Means if the fluid is so here if the fluid is going to be flowing, so work done by an agent, external agent, in forcing 3 meter cube of water. Work done equals to, generally will be getting as force into displacement. Force equal to will be rating as pressure into area into displacement will be rating. So by the external agent here you are applying the force. So pressure into area into some length you will be getting. Length is nothing but distance covered by the fluid, which is nothing but A into dx. Area into length, it gives the volume. This is the work done by the fluid pressure, the formula which you are calling as pressure energy will be called. This will be the pressure energy will be called. Pressure energy. So W equals to P into dV. This will be the formula you are taking. Next you just look at a liquid enters a section of the tube of radius 5 centimeter, and with what velocity does the liquid leaves another section of the tube 4 centimeter? The tube is horizontal, it's given. So if the tube is horizontal, let us take here according to the equation of continuity, what you can write? According to equation of continuity, equation of continuity. So here liquid enter into the tube. Here it's given as here tube is given like this. Liquid is going to be entering and is just leaving across the tube. Here this radius is given as 5 centimeter, and here another radius is given as this another end radius is given as 4 centimeter is the radius. So with what velocity is entering? 10 meter per second, and with what velocity is going to be leaving we need to calculate, that is V2. Here you can take, according to equation of continuity, the volume of the liquid flowing per second is AV is constant, A1 V1 which will be equal to, you can write as A2 V2. Across the first one you can write it as pi into R1 square into V1 which will be equal to pi into R2 square into, you can write it as V2. Pi gets cancelled. Initial radius is given as 5 centimeter, you just square. So it is 25 into 5 square, centimeter square means 1 centimeter, which will, you can write it as 10 power minus 2 meter. Whole square when you are talking 10 power minus 4 into 10 is the velocity. R2 square is 16 into, here a centimeter means here 10 power minus 4 meter square into V2 you can take. So here 10 power minus 4 gets cancelled. Here therefore velocity which will be equal to V2, which you can write it as, it's 250 by, you can write as 16. So the answer will be getting as 15.625 meter per second you are writing. So 15.625 will be the correct answer. Now look at the next question. In a horizontal pipeline of uniform area of cross section, the pressure falls by 8 Newton per meter square, it's given. So horizontal pipe is given. This is a horizontal pipe, it's given, and here the 2 points are separated by 1 kilometer distance, and here the change in kinetic energy of the oil flowing at these points they are asking. Here you can take for an horizontal pipe here according to the Bernoulli's theorem. According to Bernoulli's theorem. According to Bernoulli's theorem, for a horizontal pipe here you can write it as P1 plus half rho V1 square, which you can write it as P2 plus, here you can write it as half into rho into V2 square you can take. Then here pressure falls by, it's given. So here you can write it as P1 minus P2, which you can write it as half into rho into, you can write it as V2 square minus V1 square. So pressure for the change in kinetic energy, the change in kinetic energy per mass they are asking, that is nothing but half into mv square by mass. And this is change in the sense, here V2 square minus V1 square you can take. Here this is the requirement, half into V2 square minus V1 square. There is a change in kinetic energy, change in kinetic energy per kg. Per kg means here you can write as 1 kg you can talk, right? So this is per kg of the oil, that means here mass they are asking. That doesn't mean here you can write as P1 minus P2, this rho you have to bring this side. Our requirement is here half V2 square minus V1 square. Therefore change in kinetic energy per unit mass, which will be equal to pressure falls by, it's given as 8 Newton per meter square, it's given 8 Newton per meter square. P1 minus P2, density is given as, here 800 is given, 8 one time, here will be writing as 10 power minus 2 joule per kg you are getting. Look at the next question. Here in a horizontal pipe of liquid, here it is given as with a velocity v and leaves with a velocity 2v is given. The pressure difference between the ends of the tube they are asking. Here in a horizontal pipe of liquid of density is given as d is given, which is entering with the velocity v and leaves with the velocity is given as 2v. The pressure difference across the ends of the tube. Pressure difference we need to calculate. First here you can take it as P1 value here entering into the tube, a horizontal pipe is given. It enters with the velocity is given as V and leaves with the velocity is given as 2V. It's given. The pressure difference between the ends they are asking. Here let us take as P1 and here you can take as P2. P2 is the pressure you can take at the another end you can take. Here you can apply according to the Bernoulli's theorem. So pressure difference between the ends of the pipe means here you can take as according to the Bernoulli's theorem. Here what you can write P1 minus P2, which you can write it as half into rho into you can write as V2 square minus V1 square you can take. So P1 minus P2 which will be equal for a horizontal pipe. Here you will be writing as so P1 plus half rho V1 square which will be equal to P2 plus half rho V2 square you can take. Then P1 minus P2 which will be equal to you can take as half into rho into this is V2 square minus V1 square. Its a density is given as D is given and here that you have to substitute and this is a D into V2 square minus V1 square. It leaves with the velocity is given as 2V. 2V whole square means here we can write as 4V square minus initially it is entering with what velocity? V velocity. So the pressure difference P1 minus P2 which you can write it as this is 4 minus 1 3 by 2 into D into V square you are getting. 3 by 2 into D into V square. This will be the correct answer. Next look at a pipe is running full of water at a point A. It tapers from 200 centimeter square of cross-sectional area to 100 centimeter square at the point B. And the pressure difference here it is given. Pressure difference between the A point and as well as the B point is given as 15 centimeter of water column. The rate of volume of the water through the pipe they are asking. The rate of volume of the fluid they are asking. Here you can see a pipe is running full of water, it's given. Here let us take according to the equation of continuity. According to equation of continuity. Equation of continuity. So here volume of the fluid which is entering and leaving it will be same A1 V1 which you can write it as A2 V2 you can take. Across the first one here 200 centimeter square is an area into velocity we don't know, let us take it as V1. Across in another end here right A2 is given as 100 centimeter square. This will be 100 centimeter square. I am not going to be changing the right units. 100 2 times you will be getting, so that you can write it as V2 equals you can write it as 2V1 you can take. Now here they are asking the rate of volume of the flow of water through the pipe. Now here just look at first you need to calculate the pressure difference between the A point and as well as B point. Here one pipe is given and here it will be 200 centimeter square area and the second one is 100 centimeter square is the area is given. This is 200 centimeter square and 100 centimeter square is the area. Now here this is an A point and this is the B point you can take. First you have to calculate the pressure difference. So pressure difference here almost here it is not given anything. Here you can talk about here H remains same you can talk from the ground. Then you can write it as P1 plus according to Bernoulli's theorem P1 plus half rho into V1 square which is equal to P2 plus here you can write as half into rho into V2 square. Then P1 minus P2 which we can take as half into rho into you can take as V2 square minus V1 square you can take. Initially pressure is given as 15 centimeter of water column is given. 15 centimeter pressure difference is given as 15 centimeter means delta P you can take as H rho G you can take. Height of the water column is given as 15 H rho G. This is a formula you can apply here. 15 centimeter means 15 into 10 power minus 2 Rho in the sense density of the water value you can take as 10 power 3 into G value you can take as 10, which you can take as density of the water value will be 10 power 3 into V2 square in the sense here will be taken as 4V1 square minus V1 square you can take. Now when you are simplifying these values, here this side 10 power 3, 10 power 3 gets cancelled, here 1 10 power minus 2, 10 gets cancelled, 10 power minus 1. So here 2 into 15 will be 30, 30 into 10 power minus 1, and this side you can get it as this is 4V1 square minus V1 square will be 3V1 square will be getting. So here 3 10 times 10 into 10 power minus 1 will be 1, then V1 value will be getting as 1 meter per second will be getting. Therefore rate of flow, how much rate of volume in the sense rate of flow of volume, rate of flow of volume, that's the rate of flow means rate of flow of volume, which is nothing but here will be getting as A1 V1. Flow of the water through the pipe they are asking A1 V1. Area, initial area it's given as 200 centimeter square. Centimeter square you have to take as 10 power minus 4 into its velocity is given as here 1 meter per second. So here we'll be writing as this is here you can take as 10 alone you have to cancel, 10 power minus 3, 20 into 10 power minus 3. So 10 power minus 3 you can write it as 1 liter value. So you can get it as this is 20 liter per second will be getting. Rate of flow of volume in the sense V by T, which will be equal to, they are asking A1 V1. 1 liter which will be equal to 10 power minus 3 meter cube per second in the sense here you can get as 1 second you can do. So the answer will be getting as 20 liter per second will be getting. This will be the correct answer. Now look at the next question. Here the lift force acting on the wing of an aeroplane, it's given as 2275 newtons. If the area of the wing is given as 5 meters square and the velocity of the air on the lower surface of the wing is given, the velocity on the upper surface of the wing they are asking. Here it's given as an aeroplane wing. It's an aeroplane wing it's given, and here the lifting force is given, upthrust force is given, or lifting force is given, overall force net force is given, and here the velocity of the air on the lower end is given as here 30 meter per second it is given. The velocity in the upper one you need to calculate, this velocity we need to calculate. Let us take this is V1 you can take and this will be V2 you can talk. Here according to the Bernoulli's principle, here the net thrust or net upward thrust acting on the bodies you will be calling as aerodynamic lift, you will be calling aerodynamic lift. That means here the net force F is nothing but you will be writing as half into rho into you can take as V2 square minus V1 square into area of the wing you have taken. Here already it's given as here the lifting force acting on wing is given as 2275. This 2275 here you have to substitute, half into density of the air is given as 1.3 kg per meter cube into this area is given as 5 is given, area of the wing is given as 5 meters square into V2 square minus V1 square it's given as 30 meter per second. Here you have to substitute. Then here when you are simplifying this value, here you will be getting as 2 into 275 by here 1.5, 4.5 you can take. Then here we will be writing as 700, this is the value which you can write it as V2 square minus 900 you are getting. Then V2 square which we can get it as 1600 you are getting. Then V2 value will be getting as V1 value we can get it as 40 meter per second will be getting, 40 meter per second. This is the V2 you can talk, and here let us take as this is V1 you can take, and anyhow in the square in the sense here will be getting as V1 square minus V2 square, it's nothing wrong. Here this is V1 square you can take, this is V1, also V2 same thing you have to keep, nothing wrong, V2 square. So V2 square value will be getting as 40 meter per second you are getting. Now look at the next question. The pressure on the top surface of an aeroplane is given as 0.9 into 10 power 5 Pascal, and here at the bottom surface is given as here 0.91. The area of each surface is given as 40 meters square. The net lifting force they are asking. Here net lifting force in the sense, here there is an aeroplane you can take. Pressure on the top is given as let us take it as P1, and pressure at the bottom is given P2. So the net lift force they are asking. The net lift force according to the Bernoulli's principle, the net lift force, or it's an aerodynamic lift, the formula will be getting as F equal to, you can write as pressure difference P1 minus P2 into, you can write it as A. Force equal to pressure difference into area you can write. Therefore F equal to, you can write it as 0.91 minus 0.90 into 10 power 5 into area it's given as 40 meters square, it's given, you can multiply, then therefore F equal to here will be writing as, when you are simplifying, this is 0.91 minus 0.9, 0.1 will be getting, so here you can get it as this is 0.4 into 10 power 5, which will be equal to here you can get as 4 into 10 power 4 newtons will be getting. This is the net force on the wing. Look at the next question. The pressure on the top surface of an aeroplane wing is 0.7 into 10 power 3 Pascal it's given, and the pressure on the bottom surface is given as 0.75 into 10 power 3 Pascal. Here if the area of each surface is given as 50 meters square, the dynamic lift they are asking. So here the same question, here an aeroplane wing it's given, and here the pressure values is given. Here the pressure is given as 0.7 into 10 power 3 Pascal, and pressure at the bottom surface is given as 0.75 into 10 power 3. So this is in Pascal. Here you will be getting as highest pressure at the bottom and lowest pressure it will be due to the pressure difference. Here the aeroplane wing it will be lifted. Therefore F equal to, here you can write it as, here the dynamic lift they are asking, the dynamic lift or aerodynamic lift, which you can write it as, here it's nothing but force they are asking. Force is nothing but, here you can write as pressure difference into, you can write as area of the wing you can do. Pressure difference is 0.75 minus 0.7, in both the cases 10 power 3 you can take common into area. Area you will be getting as 50 meters square you are getting. So when you are simplifying this one, here we will be getting as, this is 2.5 into 10 power 3 you will be getting. So this one and this one you have to multiply. So you can write this one as 0.25 into 10 power 4 newtons you can write. This is the dynamic lift or force will be writing, right?